Hello friends, I am Sujit and welcome back to my YouTube channel Mission Maths Studio. I hope all of you are fit and fine and enjoying my online classes, and would like to remind also friends that already I have uploaded very first lecture of chapter matrices of class 12, and those viewers who didn't watch that video yet, please visit my official channel, watch that video and clear your concepts before I'm going to start very new topics of the same chapter matrices in this second lecture. And if you like this video, please watch this video till end, and if you like this video, don't forget to like and share with your friends too. Okay friends, so let's start. हाय फ्रेंड्स, मैं आपका मैथमेटिक्स मेंटर सुजीत त्रिपाठी। क्या आपको मैथ्स बहुत मुश्किल लगती है? तो अब मैथ्स सीखना हुआ बेहद आसान। अभी सब्सक्राइब करें मेरा यूट्यूब चैनल मिशन मैथ्स और हो जाए बेफिक्र। We will discuss first types of matrices. Very first type is column matrix, and a matrix having only one column is called a column matrix. And the order of column matrices are written as m by 1. First is column matrix, and since column matrices have only one column, so order is defined by m by 1. For example, A is a column matrix with elements 1, 2, 3, and its order is what? 3 by 1. So look, in order of the column matrices, row may be different but column is always 1. So order of a column matrix is defined as m by 1. Okay, now second type is row matrix. In row matrices, a matrix having only one row is called a row matrix, and order of row matrices is 1 by n. Second is row matrix, and in a row matrix there is only one row. So look here, order is 1 by 3 because there is one row and there are 3 columns. So order of a row matrix is defined by 1 by n, means n can be different since number of columns may be different also, so order is 1 by n. Okay, now what is next? Next is a square matrix. In square matrices, number of row is same as number of columns in a square matrix. Okay friends, that means m is equals to n in a row matrix. Okay, sorry, in a square matrix. In a square matrix there are equal number of row and columns. Okay, for m equals to n, where m is number of row and n is number of columns. So we can write an example of a square matrix of order 2 by 2. There are 2 rows and 2 columns. So in case of a square matrix, there are always equal number of row and columns. Okay, now what is the next? Next is diagonal matrix. In diagonal matrices, the square matrix in which all the non-diagonal elements are 0 is called a diagonal matrix. Okay, so in a diagonal matrix, all the non-diagonal elements are 0 and the diagonal elements may be different. Okay, for example, and a diagonal matrix is always a square matrix. 1, 0, 0, 0, 2, 0, 0, 0, 3. I give an example of a diagonal matrix. Look, in this square matrix, all the non-diagonal elements are 0 and the diagonal elements are 1, 2 and 3. Diagonal elements may be different, maybe 4, 5 and 6 also. Okay, you can take any other number, different numbers in the diagonal, but all the non-diagonal elements must be 0 in a diagonal matrix. Okay, so look here, this is the main diagonal, and in the main diagonal elements are different, 1 2 3, you can take 4 5 6 also, but all the other elements are always 0 in a diagonal matrix. So don't forget, a diagonal matrix is always a square matrix and all the non-diagonal elements should be 0 except main diagonal elements. Okay, now fourth one is a scalar matrix. So what is a scalar matrix? A scalar matrix is a diagonal matrix with all the non-diagonal elements 0 and diagonal elements are always equal. Okay, so how to define a scalar matrix? I repeat it again. A diagonal matrix in which all the non-diagonal elements are 0 and diagonal elements are equal. Okay, so in a scalar matrix, I give you example. Since this is a square matrix with non-diagonal elements 0 and diagonal elements are always equal, so this is a scalar matrix. Okay, you can take another example also of order 2 by 2 of scalar matrix. I am giving you example of scalar matrix of order 2 by 2. Look, in this example also there are non-diagonal elements which are 0 and diagonal elements are equal and they are 3. Okay, so I am sure this is clear to you. Now what is next? Next is identity matrix. What is an identity matrix? So a square matrix in which all the non-diagonal elements are 0 but diagonal elements are always equals to 1. They cannot be other than 1. Okay, so in an identity matrix, an identity matrix is denoted by capital I. So 1 0 0 0 1 0 0 0 1. So what is identity matrix? A square matrix in which all the non-diagonal elements are 0 and diagonal elements are always equals to 1. Okay, so this was about identity matrix, and at the end the last matrix is a zero matrix. So a matrix in which all the elements are 0 is called a zero matrix, and zero matrix is also known as null matrix too, and it is denoted by O. For example, null matrix or zero matrix, it is denoted by 0, and this may be different from square matrices also. 0 0 0 0 0. Look, zero matrix can be of any order, like this is of order 2 by 3, and we can take a zero matrix of order 2 by 2 also. So zero matrix may be of different order, may be a square matrix and may not be also. Okay, so this was the last definition. I would like to tell you also about a diagonal matrix. A diagonal matrix can be written like this also. If you are given diagonal of 1 2 3, it means what? You have to write a matrix of order 3 by 3, since as you know, I told you earlier that a diagonal matrix is always a square matrix. Okay, sometimes you may be given like this also. So how to write? It means this is a matrix, diagonal matrix of order 3 by 3, and the diagonal elements are 1 2 3. It means, okay, so remember this also. Okay friends, so we have discussed all the type of matrices first. Now we will discuss operations of matrices. Now how to operate two or many matrices together. In the operations, at first we will discuss addition and subtraction of matrices. How to add or subtract two or more matrices. Okay, so what is the basics? Don't forget this. Okay, matrices of same order can be only added or subtracted. Okay, I repeat it again. Matrices of same order can only be added or subtracted. For example, suppose this is a matrix 1, 2, 3, 4, 5, 6. This is a matrix of order 2 by 3, and you are adding another matrix of order 2 by 2. So, is it possible? What is the order of first matrix? Order of first matrix is what? It is 2 by 3, and order of second matrix is what? 2 by 2. What is order of a matrix? If you didn't watch the first video, in the first lecture I have explained about order of a matrix. I would like to repeat it again. Order of a matrix is basically number of row by number of columns. Okay, horizontal arrangement is number of row and vertical arrangement is number of columns. Okay, so in this matrix there are two horizontal rows, so number of rows is 2, and there are 3 vertical arrangements, so number of columns is 3, so order is 2 by 3. Okay, and similarly here there are 2 rows and 2 columns, so order is 2 by 2. Now what I told you earlier, matrices of same order can be added or subtracted. So look in this question, order of first matrix is 2 by 3, which is not same as to the order of the second matrix. So these two matrices cannot be added. Okay, we can't add these two matrices. Okay, so let us take another example. Suppose you are given now 1, 2, 3, 4, 5, 6, and another matrix is 0, 1, 5, 2, 0, 1. Now look, they are the matrices of same order. Order of first matrix is 2 by 3 and order of second is also 2 by 3. So now these matrices can be added and we add the corresponding elements together. What are the corresponding elements here? We add first row with first row here, and we add second row with second row and with corresponding elements. Like here 1 is corresponding element of 0. So you write 1 plus 0. You add 2 and 1 together, as this is the second element of first row. So you have to take second element of first row here also. So 2 plus 1, here 3 plus 5. Now add the corresponding elements of second row also. So 4 plus 2, 5 plus 0 and 6 plus 1. So this way we add 2 or more matrices. Now write the result. 1 plus 0 is 1, 2 plus 1 is 3, 3 plus 5 is 8, 4 plus 2 is 6, 5 plus 0 is 5, and 6 plus 1 is 7. So I am sure friends, now you got it how to add two matrices. Okay, similarly we can add more matrices together and subtract them also. Okay, another example of subtraction. Okay, so what is compulsory to add or subtract two matrices? That is their order. Order matters. So matrices of same order only can be added or subtracted. We have seen in this example. Okay, now another example. Suppose you have 2, 3, 4 and 5, 6, 7, and you are subtracting this time these two matrices 1, 0, 2 and 3, 2, 0. Now it's very simple. Subtract the corresponding elements and get your answer. Look, this is minus sign. So first we write this minus sign with all the elements and we use basic concept of addition. Like previous example, first you write here plus sign and change all the sign inside the matrix, -3, -2 and 0. This is the easy way. Okay, rest your choice. You can subtract them directly also. 2 minus 1 is 1, 3 minus 0 is 3, 4 minus 2 is 2, 5 minus 3 is 2, 6 minus 2 is 4 and 7 minus 0 is 7. So this is the result of subtraction of two matrices. Okay, so this way you can add the two matrices or subtract them. Okay, and order of the resultant matrix remains same to that of original matrices. Look, order of these two matrices was 2 by 3, 2 by 3, and what is the order of resultant matrix? That's also same here. Its order is also 2 by 3. So don't forget, order of matrices remains same throughout addition or subtraction. Okay. So another example. X 1 2 3. This is example of different kind. 2 4 3 0 equals what? Suppose you are given 5 5 5 and 3. What to do in this kind of examples? Now you are given addition of two matrices on the left hand side and one matrix on the right hand side. So, and find the value of x. Then how to do? So first you add these two matrices first, like x plus 2, 1 plus 4 is 5, 2 plus 3 is 5 and 3 plus 0 is 3. First you add these two matrices, and if you remember, then we did a topic in very first lecture, that was equality of matrices, equal matrices. Two matrices are equal if their corresponding elements are equal. So we can use that concept here now. Now these two matrices are equal, so their corresponding elements must be equal. Okay, very first element is x plus 2 and here first element is 5. So we can equate them by equality of matrices. By equal matrices, we can write x plus 2 equals 5, and so value of x is 5 minus 2, which is 3. Okay, so you can solve this way, and there are so many questions in your exercise of this kind also. You can try all of them. Okay, there are a lot of questions on addition, subtraction and of this kind also. Okay, so we have completed addition and subtraction of matrices. Okay, so please you try all those questions based on the addition and subtraction. Okay, multiplication of matrices. When multiplication of two matrices is defined, let's discuss. Suppose you are given two matrices, matrix A and matrix B. Okay, then A into B is defined if number of columns in matrix A is same as number of row in matrix B. Only then multiplication of matrix A and B is possible. Okay, only then multiplication of this order is defined. Otherwise you can't multiply them. For example, suppose you have a matrix of order m by n and another matrix of order n by p, then look what is common there. Number of columns in matrix A is same as number of row in matrix B. So this product is defined. This is possible. We can multiply them in this order. Okay. And suppose you obtain a resultant matrix C, then what would be the order of matrix C here? So order of the resultant matrix is always number of row in the first matrix by number of columns in the second matrix. Okay, basically we cancel the common things here. Columns and rows are same here, so we can cancel them. So what is left? Or row of the first matrix and column of the second matrix. So order of the resultant matrix is always number of row in the first matrix by number of columns in the second matrix. Okay, so this multiplication is only defined when number of columns in the first matrix is same as number of row in the second matrix. This was about compatibility of multiplication of two matrices. Okay, when multiplication B into A is possible, so look, B into A is also possible if columns in matrix B is same as rows of matrix A. Okay, only then we can multiply in the order B into A. Okay, for example, if the order of matrix B is suppose anything K by P and order of A is P by R, then that means look here, number of columns in B is same as number of row in A. So this multiplication is possible. Okay, and suppose you obtain the resultant matrix R. So what would be order of this matrix? So as we discussed above, the number of row in the first matrix by number of columns in the second matrix, this would be order of the resultant matrix. Okay, now we will, if this condition is not satisfied for the two matrices, then their multiplication is not possible. Okay, now we will take a few of examples for multiplication of two matrices to clarify your concept. Okay, A is a matrix of order 1, 2, 3, 4, 5, 6. So what is the order of this matrix? Here order of this matrix is 2 by 3. Okay, now assume another matrix B, that is the matrix with 1, 2 only. So what is the order of this matrix? This is of the order 1 by 2. So look, if A into B is defined here, so let's check. When A into B is defined, number of columns in matrix A must be equals to number of row of matrix B. So we can see here 3 is not equals to 1. So multiplication is not possible. Okay, because the condition is not satisfied here. So let's check whether B into A is possible. Okay, for B into A, look, number of columns in B matrix, yeah, it's 2, must be equals to number of row in matrix A. What is the number of row in matrix A? Yeah, it's 2. So this condition is satisfied here. Okay, number of columns in B is 2 and number of row in matrix A is also 2. So this multiplication is defined. This is possible. Okay, so how to multiply them? Look, let's multiply B into A. So you write like this, 1, 2, this is first matrix, multiplication, second matrix 1 2 3 4 5 6. Okay, now look how to multiply them. We always multiply row with columns. Okay, we multiply first row with all the columns by putting space between columns. Okay, so multiply R1 with first column and we multiply the corresponding elements always. We multiply first element of the row with first element of the column and multiply second element with the second element of the column always. Okay, and add the results. So look, 1 into 1, what do we obtain? 1 into 1 is 1. 2 into 4 is what? 8. Now first row is multiplied with first column. Now we have to multiply with second column. Between these two columns there is a space, so we need to put here space and then multiply with second column. So 1 into 2 is 2 and 2 into 5 is 10. Okay, so multiplication of this row with second column is done. Now one more column is there, so we multiply this column, this row with the third column also. How to do? 1 into 3 is 3 plus 2 into 6 is 12. Is there any more row in this matrix? No more, only one row was there, so multiplication is now complete. Okay, so simplify this. 1 plus 8 is 9, 2 plus 10 is 12, 3 plus 12 is 15. So this is the multiplication result of B into A. And what is the order here? Order is 1 by 3. There is one row and 3 columns. Look, so order is 1 by 3. So this way we can find multiplication of two matrices. Okay. Now I am giving one more example. This was the product of matrices which are not square matrices. Now I will give you example of product of two square matrices. Okay. And you know, product of square matrices of same order is always defined. No need to check whether their multiplication is possible or not. The multiplication of square matrices of same order is always defined. No doubt about it. So look, now if we have a matrix 1, 2, 3, 4 to multiply with another matrix of same order 0, 2, 1, 3. Look, it's very easy. As we discussed earlier, multiplication happens always of row with column. So first you multiply first row with first column. 1 into 0, you can write like this for more clarification. 2 into 1, just write like this. Now multiplication of R1 with C1 is over. Now column changes, we multiply this row with second column. There is a space between column 1 and column 2, so we need to put here space. And now multiply 1 into 2 and plus 2 into 3. So write like this. Now multiplication of first row with all the columns is done. So first row is obtained here. Now we are moving towards second row. Multiply second row with first column and write the result in second row. 3 into 0 plus 4 into 1. We always multiply the corresponding elements. Now multiply this row with second column. So 3 into 2 right there plus 4 into 3. Multiplication is done. Now simplify to obtain your result. 1 into 0 is 0 plus 2 into 1 is 2. 1 into 2 is 2 and 2 3s are 6. So 6 plus 2 is 8. 3 into 0 is 0 and 4 into 1 is 4. 3 2s are 6 plus 4 3s are 12. So 12 plus 6 is 18. This way we can multiply a square matrix with another square matrix of same order. Okay, so this was all about multiplication. And remember, matrix multiplication is never commutative. It's not necessary A into B is always same as B into A. No. Under some conditions, under some special conditions, matrix multiplication is commutative. What are those conditions? I tell you. Matrix multiplication is commutative if A into B, one of the matrix is identity matrix. A into identity is identity into A. So this is the first condition when matrix multiplication is commutative. If you multiply a matrix with identity matrix, then it is possible. That product is commutative. Otherwise, no. What is the second condition? Second condition is A into B is same as B into A. Means multiplication is commutative if their product is identity. That means what? If the product of A into B comes identity matrix and B into A is also identity matrix, only then product is commutative. We say these two matrices are invertible. What is invertibility? We will discuss later. Okay, so these are the two conditions when multiplication of matrices is commutative. Matrix multiplication is not necessarily associative also. Okay, so what is associativity? You can try questions from your textbook for that. Okay, so this was all about multiplication of two matrices. दूसरा एग्जांपल लेते हैं. एक मैट्रिक्स स्क्वायर मैट्रिक्स लेंगे A और A स्क्वायर हम फाइंड करेंगे. ओके, सो लुक, इफ A इज अ मैट्रिक्स 1 2 3 3 0 1 minus 1 1 and 2. Suppose A is a matrix of order 2 by 2. Then how to find A square, A multiplied by A. अब इसका हम एग्जाम्पल देखेंगे. So basically A square is what? A matrix into A. As this way we can find A square. So what to do now? Let's put here this into 1 2 3 3 0 1 and 1 1 2. Now let's multiply them. So as we know that we multiply row with column. Okay, so first we multiply R1 with C1. We multiply R1 with C1. First you multiply and then you add. We multiply always corresponding elements. Okay, first element of first row will be multiplied with the first element of first column. Okay, second element of first row will be multiplied with second element of the column, like that. So 1 into 1 is 1 plus 2 into 3 is 6. It's like this: 1 into 1, 2 into 3 and 3 into 1. So it's 3. Now look, first row is multiplied with first column. Now after first column we multiply R1 with C2. So column changes, there is a space between C1 and C2, so we put here a space. Again you multiply in similar fashion: 1 into 2, first element with first, second element with second. 2 into 0 is 0 and 3 into 1 is 3. Now we multiply R1 with C3. So again you put space here. 1 into 3 is 3, 2 into 1 is 2 and 3 into 2 is plus 6. So we multiply in this way. Now we have multiplied R1 with all the columns. Now row changes, we multiply second row with all the columns, so we write the result in second row. So we multiply R2 with C1, 3 into 1. We multiply first element of this row with first element of this column. 0 into 3 is 0 and 1 into 1 is 1. Now you multiply this with second row. 3 into 2 is 6 plus 0 into 0 is 0 plus 1 into 1 is 1. Now multiply this with third column. 3 into 3 is 9 plus 0 into 1 is 0 and plus 1 into 2 is 2. Now we have multiplied second row with all these columns. Now we multiply the third row with all these columns. So let's multiply with first column. 1 into 1 is 1, 1 into 3 is 3 and 2 into 1 is 2. Now multiply this row with second column. 1 into 2 is 2, 1 into 0 is 0 plus 2 into 1 is 2. Now multiply this with last column. 1 into 3 is 3, 1 into 1 is 1 and 2 into 2 is 4. So this way multiplication is complete. Now simplify these terms and get your answer. So if you simplify, then you obtain 10, 5, 11, 3 plus 1 is 4, 6 plus 1 is 7, 9 plus 2 is 11, this is 6, 4 and 8. So this way we obtain a square. This is the value of a square. Okay, so I'm sure it's very clear to you how to find out a square of a matrix. Okay, multiply the same matrix with itself like this. Okay, mostly we are given the multiplication of square matrices. Okay, multiplication of square matrices is very useful. Okay, and you will get frequent questions. Okay, on the multiplication of square matrices. Okay friends. Okay, so what is next after multiplication? Now next topic is transpose of a matrix. How to find multiplication of a matrix with a scalar. How to multiply a matrix with a scalar. So this is basically what? If A is a matrix, A is a matrix 1, 2, 3, 4, then multiplication of this matrix with a scalar. Suppose if I ask you to find out k into A, where k is any constant. So how to do? Just multiply all the elements with k. 1, 2, 3, 4. So multiply all the elements with this constant. You obtain k, 2k, 3k, 4k. So this is the way to multiply a matrix with an scalar. Okay, another example. Suppose this is a matrix A. Now I ask you to find out 3A. So what to do? Multiply 3 with all the elements of this matrix. 3 1s are 3, 3 2s are 6, 3 3s are 9 and 3 4s are 12. So this is the way to multiply a matrix with an scalar. Okay friends? Okay, you got it. Now next topic is transpose of a matrix. How to find transpose of a matrix and what is transpose of a matrix? So I tell you, transpose of a matrix is written as transpose of a matrix. If A is a matrix, then its transpose is denoted by AT or A dash. A transpose is denoted by AT or A dash. Okay, this is called transpose of a matrix. And what is transpose of a matrix? So basically, in transpose of a matrix, we interchange row and columns together. Row becomes column and column becomes row. For example, so transpose of a matrix is basically interchange of rows and columns. Suppose you are given a matrix A 1, 2, 3, 4, 5, 6 and its order is 2 by 3. Then a transpose of this matrix will be interchange column. First row becomes first column 1, 2, 3 and second row becomes second column. So this is transpose of matrix A, and what is its order? Its order is 3 by 2. So basically order changes. Okay, whenever we find transpose of a matrix which is not a square matrix, then order always changes. Look here, there were 2 rows 3 columns and now 3 rows 2 columns, and look, R1 becomes C1 and R2 becomes C2. So basically transpose of a matrix is interchange of rows and columns together. Okay, another example, suppose A is a matrix 1, 2, 3. This is a row matrix and order is 1 by 3. So what about its transpose? Interchange row and columns. R1 becomes C1. So you obtain 1, 2, 3 and now order is 3 by 1. So this way we find transpose of a matrix. I hope it's very clear to you now. Okay, let's see some properties of transpose. Properties of transpose. A, what is transpose of A transpose? Is itself A. If you obtain transpose of a transpose matrix, then it's original matrix always. You obtain the original matrix. Okay. Now, what is next? A plus B transpose or A minus B transpose is same as A transpose plus or minus B transpose. This is another property. Next is K times A transpose is same as K times A transpose. This is the third property. Next is A into B whole transpose is same as B transpose into A transpose. This is very important. This is very important property. So these are the properties, useful properties of transpose of a matrix. Okay, and you will get question on these properties. Okay, so remember, especially remember the last property. This is very useful. Now we will verify this property with the help of an example. Okay, look, to verify this, let's take two matrices, matrix A and B of the order 2 by 2. You can take any other matrix also of order 3 by 3. Okay, so let's, A is a matrix 1, 2, 3, 4 and B is another matrix 0, 1, 3, 0. Okay, so how to verify this? First we will check left hand side. just solve left hand side. For that, you find A into B first, then its transpose. So let's multiply A into B. As you know, in multiplication of two square matrices or in multiplication of any matrices, we multiply row with column. Okay, so multiply first row with first column, then what do you obtain? 1 into 0 is 0 and 2 into 3 is 6. In multiplication, we always multiply corresponding elements of row and column. Okay, so 0 plus 6. Now you multiply this first row with second column. Then you obtain 1 into 1 is 1 and 2 into 0 is 0. Okay, now you multiply second row with first column and then with second column. Then you obtain these two results. 3 into 0 is 0. 4 into 3 is 12. Okay, now multiply this row with second column. 3 into 1 is 3 and 4 into 0 is 0. So we obtain the multiplication A into B as 6, 1, 12 and 3. This is the matrix of A into B, but what was required there in left hand side? We need A into B transpose. So find its transpose now. What is transpose of a matrix? Interchange of row and column. So R1 becomes C1 and R2 becomes C2. So this way we obtained LHS, left hand side, A into B whole transpose. Okay, now we will find right hand side. What is that? That is B transpose into A transpose. So first you find transpose of the two matrices by interchanging row and columns. Transpose of A matrix is 1, 2, 3, 4. R1 became C1 and R2 became C2. What is transpose of B matrix? R1 was 0, 1, so that became C1, and R2 was 3, 0, that became C2. Okay, now multiply B transpose with A transpose. So write B transpose first and then A transpose. Okay, and multiply in the same fashion what we did here earlier for A into B. Okay, multiply, we always multiply row with column. Okay, so start with R1 to multiply with C1 and then multiply R1 with C2. So what do we obtain? 0 into 1 is 0, 3 into 2 is 6. Okay, now multiply this with second column. 0 into 3 is 0 plus 3 into 4 is 12. Okay, so multiplication of first row is completed. Now multiply second row with first column and then with second column. So 1 into 1 is 1 and 0 into 2 is 0. 1 into 3 is 3 and 0 into 4 is 0. So what do we obtain? Multiplication of B transpose and A transpose. We obtain 6, 12, 1 and 3. So look the two results. A into B whole transpose is 6, 12, 1, 3 and B transpose into A transpose is also 6, 12 and 1, 3. That means A into B transpose is same as B transpose into A transpose. Hence we have verified this property, which was very important. Okay, so I tried to make your concept clear with the help of this example. Okay, so this is done. Okay, this is symmetric matrix. What is a symmetric matrix? If transpose of a matrix is itself, then it is called symmetric matrix, and a symmetric matrix is always a square matrix. So symmetric matrix, condition for symmetric matrix is A transpose is itself. Okay, I give you an example. If A is 1, 2, 3, 4, 0, 0, 4. Okay, now let's verify. Find A transpose and see whether it is itself or not. If we find A transpose, R1 becomes C1, R2 becomes C2 and R3 becomes C3. So write R1 as C1, R2 as C2, and R3 as C3, and then check whether this is the same matrix that of original or not. So let's check. 1 2 3 1 2 3 2 4 0, yeah, it's same, and third row is also same. So this condition is verified. So we can say that A is a square matrix and this is symmetric also. Okay, so this was symmetric matrix. Now next is skew-symmetric matrix. What is the condition of a matrix to be skew-symmetric? So condition of skew-symmetric matrix is just A transpose is negative of A. What was symmetric matrix? Symmetric matrix was A transpose must be equals to A only. But now for the skew-symmetric matrix, condition is A transpose equals negative of A. Okay, now we will verify this condition also. So I give you another example. If A is a matrix and diagonal elements of a skew-symmetric matrix is always 0. So remember, skew-symmetric matrix is also a square matrix and all the diagonal elements are always 0. So if A is 0, 1, 2, minus 1, 0, 3, and minus 2, minus 3, and 0. So look, as we discussed that diagonal elements are always 0 for a skew-symmetric matrix. Now find its A transpose. If you find here A transpose by interchanging row and columns, so R1 becomes C1, then R2 becomes C2, minus 1, 0, 3, and R3 C3. Now let's check. Then you will obtain the difference of minus sign only. Look, here 1 is positive, there 1 is negative, 2 is positive and 2 is negative. That means we obtain all the elements, okay, they are equal but opposite in sign. So what was the condition? A transpose is negative of A. Okay, so now find negative of A. If you find negative of A, that would be equals to A transpose. So change all the sign here. 0, minus 1, minus 2, plus 1, 0, minus 3, 2, 3, and 0. So now check whether the condition is satisfied or not. A transpose is same as negative of A. Oh yeah, it is correctly same. So therefore we have verified that A transpose is negative of A. So that means condition is verified here. Okay, so we discussed earlier about symmetric matrices and skew-symmetric matrices. Okay, now next is, if you are given a matrix A, then A plus A transpose is always symmetric and A minus A transpose is always skew-symmetric. Okay, if you are given a matrix A, then A plus A transpose is always symmetric. Remember the fact. We will verify also. Always symmetric. Now take a matrix, and as you know, symmetric matrices are always square matrices. So take an example of a square matrix. Suppose A is 1, 2, 3, 4. Now you find its transpose. What is transpose? Just interchange the row and columns. Then you obtain 1, 2, 3, 4. Now what to do? Find their sum. So if you find their sum, that should be a symmetric matrix. Let's check. If you add A and A transpose, as you know, matrices of same order can be added or subtracted only, and we add the corresponding rows. Okay, so 1 plus 1 is 2, 2 plus 3 is 5, 3 plus 2 is 5, and 4 plus 4 is 8. So we obtained A plus A transpose. Now what is given? A plus A transpose is always symmetric. Okay, that means we need to find its transpose now. If we find its transpose, that must be equal to itself only. So find its transpose by changing row and column. R1 became C1 and R2 became C2. Oh, this is same. Look, they are the same matrices. So condition is verified that A plus A transpose whole transpose is same as A plus A transpose. So the fact is verified here. So remember, whenever you are given a matrix, if you add its transpose to the original matrix, the result is always symmetric. Okay. Now what is next? Next is A minus A transpose is always skew-symmetric. Okay, and we will check that also with an example. Okay, so let's do. Okay, we are doing some changes here. Second, A minus A transpose is always skew-symmetric. Okay, so if A is a matrix 1, 2, 3, 4, find its A transpose first, and then you subtract them. If you subtract them, just subtract the corresponding rows. 1 minus 1 will be 0, 2 minus 3 will be minus 1, 3 minus 2 is 1, and 4 minus 4 is 0. Oh, look, here diagonal elements are 0. Oh, okay. Remember, I told you that in a skew-symmetric matrix, diagonal elements are always 0. Okay. Now what to do? If A minus A transpose is skew-symmetric, then what to prove? A minus transpose of A minus A transpose must be equals to its negative. So find transpose of this matrix. Then you obtain 0 minus 1 and 1 0. This is transpose of A minus A transpose. Now check, they are opposite in sign. Okay, so what to do? If you change all the sign here, then what do you obtain? Minus 0 1 minus 1 0. So this is what? No, like this. If you take a minus sign here common, then all the sign changes, and this was what? A minus A transpose. So this is basically equals to A minus A transpose. So the basic concept was, for a skew-symmetric matrix, transpose of the matrix must be equals to negative of itself. So here we have verified condition of skew-symmetric matrix also. So remember the result, A minus A transpose is always a skew-symmetric matrix. Okay, so this was the concept. I would like to recall you some concept, important concept regarding multiplication always. In multiplication, we did that multiplication of matrices is not commutative. Okay, so multiplication of matrices is not commutative. This is the first. Okay, not commutative. Okay, but when the multiplication is commutative, in some important cases, few of the cases, multiplication is commutative. But what are the conditions? If two matrices, product of two matrices is commutative if they are invertible. They are invertible means if A inverse is B, okay, this is the condition of commutativity. Multiplication is commutative if and only if their product is a identity matrix. Basically, if they are the inverse of each other, or A into identity matrix is same as I into A. Okay, so these are the two conditions when matrix multiplication is commutative. Otherwise, they are not commutative. So remember this fact also. What is meaning of A inverse equals to B? It means what? If A inverse is equals to B, then if you multiply A inverse with B, you obtain identity matrix. So remember the result, A inverse into B is identity. So remember, we discussed earlier commutativity of two matrices here. Okay, so we covered in today's lecture all the important things regarding addition, subtraction of matrices, multiplication and transpose of a matrix, and all the types of matrices as well. So please revise all the things, keep watching my videos and to clear your concept. And if you like my videos, don't forget to like and share with your friends also. Okay, so till then, we'll see you in the next video again. Till then, bye, take care.